All right, so we have a continuous random variable. We've got lengths of time in days that a bacteria lives. So our function f of x takes on this shape over here. So we can use it to determine our probabilities that x is between 2 and 3. So we want to know what's the probability it lives between 2 to 3 days. So I'm going to come over here and say days. And up here, this will be my y is equal to f of x. And I can see that this is sort of, it looks like a negative absolute value function. But if I want to find 2 to 3 days, well, here's my 2 and here's my 3. So really what I'm looking for is this area here that's under this curve. And I call it a curve even though it's a line, even though it's not curves. So looks like I could take my rectangle, think about a rectangle and a triangle up here. So if I've got my rectangle, I've got one this way coming up this direction. Let's see, we've got 1, 2, 3, 4, 5 of those. So we must be counting by 0.02s, so 2/100ths is what we're counting by. So then this distance here is going to be 4/100ths, and my distance up until this point is going to be 1.8. And so this distance here, not the total height. My total height here, of course, is going to be 1 point, no, this is 0.08. This is 1.2, 0.12, excuse me, goodness gracious. All right, so now that I've read my graph correctly, I can say that my probability is going to be equal to 1 times 0.08 plus half times 1 times 0.04. So this is going to end up being 0.1 is my total area. So that's also going to be my total probability. 6 to 8. So 9, 8 is over here. And 6, it's too bad it's not symmetric, because then I could just add the whole thing. But here's my 6. So again, I could do the same thing. This time, I'm going to have 2 over here, same height here, 0.08. This height, 2, 4, 6, same height. All right, so I'm going to have 2 times 0.08 plus a half times 2 times 0.08. That'll just be 0.08. And I'll end up with 0.24 as the probability. I can see that this area is greater than this, so it makes sense that I have a greater probability. If I went from 0 to 10 for this, well, 0 to 10 is where the bacteria is living. It looks like it never lives more than 10 days, never lives less than 10 days, so that's going to be 1. If I'm going to think about mean and variance, well, I know that mean is going to be, I'm going to sum up all my x values and multiply them by their probabilities. If I sum up all my x values, so for discrete, I know that mean is sum of x divided by, for discrete we can think of it in terms of our probabilities. So it's the sum of my probabilities of x times x values. Well, for continuous, when I look at area under the curve, it's like I'm summing the whole curve, and my probabilities are given by finding the area. So similarly, I could say that mean for a continuous function is going to be my integral from whatever my domain is, so in this case 0 to 10, of x times f of x. So again, I'll have my x values just like I did here, and then times the probabilities. Like we said, later we're going to learn how to do this in our calculator. So right now we don't know how to do this just by looking at it, but this is how we would do it using our knowledge. And variance, well, we know that variance for discrete, let me come over here, variance is going to be e of x squared minus e of x whole quantity squared. Well, I'm going to have the same thing with continuous. I'll take my integral of x squared f of x dx, and I'll subtract the square of my mean. So to save myself space, I'm going to write x squared. If I think about what mode means, mode is the most common, it's the highest probability, therefore it's the maximum of the graph. The median is going to be where the area is 50%. So in this case, because we have this symmetric graph, in both situations, our mode is going to be 5, our median is also going to be 5, but we're going to look at other examples coming up where that's not the case.